Alexa, stop. Ah!
No, I am more influential. I will prove it.
Welcome back to Khan Academy. Today we are dealing with two functions, k of t and o of t, and we're going to learn how to find the area between them. This is quite an interesting example as these functions represent the subscriber rate of this channel, Khan Academy, and the much inferior channel, the Organic Chemistry Tutor. To find the area between two curves, you want to take the integral of the top function minus the bottom function from a to b. This is because the integral from a to b of the top function minus the bottom function in terms of x is equal to the integral from a to b of the top function in terms of x minus the integral a to b of the bottom function in terms of x by integral rules. So if we imagine these in terms of Riemann sums, we first take the Riemann sum of the top function, and that is denoted in yellow, and then you take the Riemann sum of the bottom function, which is denoted in green and yellow, and when you minus the bottom function from the top function, you are left with just the space between the top and bottom functions. This problem is interesting, however, because the top and bottom function change 3 times, so we need to use 3 different integrals. You see the first section is from t equals 7 to t equals 15, where the top function is k of t, and the bottom function is the line y equals 0, or the x-axis. And then at t equals 15, the graph O of t passes the x-axis, so the top function is still k of t, and the bottom function is O of t. And then one final time, when these two graphs k of t and O of t intersect, you need a new integral where O of t is the top function and k of t is the bottom function, which ends at t equals 25. So to find that intersection point, you want to input both functions into the y equals section of your calculator, then go to the window and set the window to what's relevant for this problem. So the x would be 0 to 25, which is 2000 to 2025, and the y would be 0 to 10, which would be 0 to 10 million subscribers. Then hit graph to pull up this function, and go to second, calculate, and press 6 to find the intersect of these two functions. You want to move the left bound as close to the intersection as possible, and then move the right bound to the right of the intersection just above where it happens. Click enter, and you get the intersection point. And then you get the answer, which is x equals 24.617, and that is the time that Organic Chemistry Tutor passed Khan Academy. So now we can calculate the results of these integrals by going to Math 9 in your calculator to pull up the integral function, and then putting in the bounds, including the intersection point we just found, and doing the top function minus the bottom function for each integral. On screen currently is the result for the first two integrals, and here's the result for the third integral. So here we have our computed integrals, and the units here are extremely interesting, because as we know, the area under a curve of a value function is equal to the accumulated value over time, or whatever is on the x-axis. So in this case, it is million subscriber years. It is the unit we're using because the y-axis is in terms of millions, and the value of these functions are in subscribers, and the t-axis is for time in years. So in interval 1, this channel, Khan Academy, had 15.849 million more subscriber years than the Organic Chemistry Tutor because they had 0 subscriber years during that time. In interval 2, this channel had over 33 million more subscriber years. And in interval 3, the Organic Chemistry Tutor, just a tiny, tiny bit more million subscriber years, with less, much less than a million subscriber years. So we could use this value as a measure of influence, as it considers both the subscribers these channels had and the time that they had that influence. So if we want to measure for the total amount more influence that Khan Academy had over the Organic Chemistry Tutor channel from 2007 to 2025, we can set the time that the graph of Khan Academy is above the graph of the Organic Chemistry Tutor, positive, and set the small, small amount of time that the Organic Chemistry Tutor had more subscribers than Khan Academy as negative, and add up the intervals, and we get over 48 million subscriber years in Khan Academy's favor. So when we interpret this number, it is clear that the Khan Academy YouTube channel is far more influential than the Organic Chemistry Tutor YouTube channel since their creations. And we found this using the area between two curves.
Silly con.
Welcome back to another organic chemistry tutor video. Khan Academy posted a video about finding the area between two curves, interpreting the meaning and context, the context being our subscriber growth, but I disagree a little bit about the interpretation, so let's jump into it. We're going to calculate the area of the region bounded by the equations here with respect to y. So first let's go over the general equation. It'll be area equals a to b, which are our bounds, which will be y values. F of y will represent our rightmost function, minus g of y will represent our leftmost function. That will give us our width, and d of y will give us our height at infinitely small periods. So our first step is to change the equations in terms of t into terms of y. So we will do that by solving for what t equals. So for our first equation, we will multiply over 2.019. And then add 7 to both sides. For second equation, we will multiply 10.6 to each side. Square root both sides. And then add 15 to both sides. Now we can take a look at our graph of the two functions. So it's important to know that when you're integrating with respect to y, and the left or right functions change at some point in the interval, you're going to need to split the integral into separate parts. So if you look here, we see our first integral will be this part. And then if you look closely here, you'll see that we have two integrals in this small section of the circle. One from this part, right here between the black point and the red point, and another between the red point and the blue point. And it's kind of hard to see, but I'll show you how to solve for all these in the calculator. Now to set up these integrals, we'll do math 9. The first one is from 0 to 8.72577. The rightmost function is our blue function and the leftmost is our red. So do red minus blue, as you can see me plugging in here. I'll be using x instead of y for ease of use in the calculator. And we will get 48.89. The next one is from 8.72577 to 8.92. And here, the right function changes to our red function, while the left function changes to our blue function. So we will do red minus blue. And we'll get a value of 0.23. And finally, it will be 8.92 to 9.42. Here, the rightmost value is x equals 25. So we'll do 25 minus our left function, which is our blue function, and we'll get 0.07. And to get the total area between the two curves, we will have to add all of these together, and we'll get 48.99. Going back to the context of the problem, the red line represents Khan Academy's subscribers, and the blue line represents mine. And all numbers are scaled down by a million. So Khan Academy argues that you get a positive result of 48 million in his direction, but he didn't account for the time period between 7 and 15, in which my channel didn't exist. So I'm going to be taking the integral from this period, and for the respective time, I'm not going to be showing it, but you get a value of 15.85, and if you subtract that from our answer of 48 million, you are left with 33.14 million, which is still a favorable amount in Khan Academy, but much less than the initial result. So now that Khan Academy has proved his greater influence, let's look at the future of both of our channels by taking the derivative at t equals 25 to show our future growth. So first we would be entering the equation of my own channel. We will have to use the equation in terms of t in order to correctly derive. And we see that for my equation, you get 1.87 or 89. And when we do the same derivative for Khan Academy's channel, we see that we get a much lower number of 0.495, which shows that the future growth of my channel is much higher than of Khan Academy's. So Overall, when you consider the time period where both channels exist, Khan Academy's historical influence drastically decreases, and the future of our channels looks to be in my favor. Thank you for listening.
No. You.
What?
Good job, man.
Oh, thank you.
Nice job, nice job. Better luck next time.
The valedictorian is the organic chemistry tutor. Salutatorian is Sal Khan. Thank you for being here, everyone.